Good morning, all. Thank you so much to join this meeting. We have COFCO International come up with this project proposal of a wet dock digital twin. We, as a COFCO group, we have a mission to reduce target, and we are looking to increase efficiency and decarbonize on the freight shipping side by applying new technology which can help us to navigate through the new challenge of getting to zero emission of 2030. By that, we strongly believe that a digital twin could become a very interesting and useful tools for the next year to come. What is the wet dock digital twin? Why is not moving? One sec. There you go. So a wet dock digital twin creator is a downtime solution to retrofit the existing dry bulk vessel with an accurate digital twin using underwater robots and cloud analysis. So digital twins represent the physical, basically, asset of the vessel. In dry bulk sector, we have many different kind of vessel, which are usually categorized by size. Mainly, we operating in Capesize, Panamax, and Supramax ships. These kind of vessel are usually built under a similar design and on, let's say, well-known and developed shipyard. The idea of the digital twin will be a mirroring in real-world condition and performance and behavior of the actual vessel in the water. That's would reflect the ship current condition, integration, and historical data, and as well influence of the previous trading, and as well maintenance of the ownership during the time. So for the ships, that involves simulating performance under, as I said, the different sea states, weather condition, loading and loading scenario. By creating a digital twin, will help to control the system, optimize the voyage together with the new tools of digitalization that we are exploring at the moment, and all with the scope of improving the efficiency during the sea passages. During the design, the design of this digital twin, there are different phases that we need to develop. The first of all will be the testing model. I create a pro forma, let's say, or a already based twin on the basis of the original design of the shipyard, which need to be validated, assessed performance already with the weather routing models already present, and then connected with the physical vessel. In a sense, we want to close the gap between what is the design vessel and what the vessel actually shape is, and will adjust during that operational period. The way of create this digital twin is usually being done today at at the dry dock or before the vessel actually get delivered. Now, the problem the current community faced is the fact that there are today in the water already about 7,000 units of vessels, and obviously, if we want to dry dock or put that in a dry, we want to dry the vessels just to create a digital twin, that will create two main problems. The first one will be that we will not see the actually shape of the vessel within the water with the different adjustment the seals get physically when it is sustained in the water. Second will be economically expensive due to the fact that to do this operation the vessel will not be in full service. So the idea to have to create these the twins of the vessel when the vessel is in the water and perhaps is conducting other operations such as bunker operation or loading and discharging operation will basically maximize the utilization and minimize the time spent to create these new digital twins. The idea is to create a robot with an advanced underwater navigation system and with the sensor which will navigate the vehicle autonomous within the water. The initial target is to create these twins for the most common vessel, i.e. Kamsarmax, Panamax, and Supramax vessel built between 2005 and 2025, initially focused on major shipyard such as a Japanese and Chinese design, delivery a license subscription to the portal providing searchable twins, report live monitoring and operation of the vessel in the way that this product could be resold or been utilized to mainly brokers, owner, and charterers, so cover all shipping community. The digital twins are mostly created to pre-construction design with a lack of accurate formation. Actually, we already covered this part. So how we actually get and develop that. The challenge for the creator will be to create an advanced underwater navigation robot, which will integrate a deep learning and sensor technology to navigate and print it the shape of the vessel within the water. The robot will need to be installed with a sensor package of 3D liner sonar, HD optical imaging, interval navigation, and environmental sensor to look at the actual condition of the hull. Create a geometry, imagining and following the AIS operation of the vessel and coordination, and basically the system to basically transmit that within the system. Then once the robot will be, let's say, created and functional, there will be the second stage of the project, which is developing the platform. Following the prototype of the AUV and ROV with modular sensor layout, perception and mapping of the sonar to mass reduction, photogrammetry, and full coating analysis. The third point will be a data functioning and modeling, combining the hull geometry, loading condition, historical voyage data, estimated resistance and performance. And then will be the fourth point will be the validation of the data, comparing to the wet scan twins with the dry dock baseline pilot and in-service performance data. Yeah, I think so. So, and basically, the last point will be that eventually the third stage, when this system is up and running with the long-term counterparty, the third stage will be trying to develop this system for short customer or utilization of a vessel on short time charter or voyage. And I think we are running a bit out of time, so I guess we can follow up with the rest if anyone is fully interested, and I would leave the time for people to actually ask question if that's okay with all the participants. Thank you.
Thank you, Salvatore. That was a great presentation. If a reminder to participants, if anyone has a question for COFCO International, you're free to type it in the chat box now, and I will help you to raise it to the presenters. So far, we don't have any questions yet, but while our participants send us questions, I do have a couple of questions of my own. So, Salvatore, when you speak of installing a digital twin while a vessel is in service, what are the biggest operational constraints that you anticipate? Is it the downtime during the sensor installation, or is it the connectivity, or is it the training of the crew? So, what can the participants actually take care of so that they help reduce as much friction as possible on your end?
Well, thank you so much for the question. The reality is that the engagement with the crew and the actually creation of the digital twin will be pretty much will be quite low because fundamentally these submarine or these robots, which fundamentally will be a 3D scanner of the hull, will operate in the water while the vessel is doing other operations. So the biggest challenge would be, of course, in case, for instance, of Singapore, we are conducting bunker operation, make sure that the coordination between the barge line on the side of the vessel will be moved or will be coordinating with robots under the water, creating the actually scan. So, of course, for the crew on board will be to follow both operations at the same time. So probably we required a watchman not only to follow not only following the actually twin in the water, but perhaps the officer to conduct, as is already are doing it, the bunker operation. Similarly, during the discharging operation, probably the twin will be able to scan, let's say, only half of the job because the vessel will lie on the side on the dock. So probably the second part will need to be conducted in the moment the vessel finish the operation, or perhaps when will leave the dock at the end of the voyage. So that as well will require probably some let's say time without getting too much into the technicality. Then after discharging, the vessel will have a different draft, and so the full scan will not be bad. But that is too much technicality. Let's put it this way. We can look at the second stage.
Okay, understood. And from a business case perspective, there's an emphasis on the return on investment. So there's energy, fuel, and greenhouse gas savings. So in terms of the level of savings or the timing of the payback that you're looking at in terms of the return on investment, um, what kind of savings would help COFCO be comfortable with investing at scale? And how would you verify those savings?
Well, let's put it this way. Today, let's say improve efficiency at the sea, we are using different tools, mainly digitalization tools and digital routing systems, which on the paper are able to provide between 2 and 3% of saving at the current stage. We think that with the proper twin of the hull, together with the others, other twins can be engine and high frequency data at sea, we could probably get and be in excess of 5%. Now, the time of return will depend it more on the scalability of the project and how long will takes to get to that stage.
Okay, understood. And speaking of scalability, so assuming that we have an operational digital twin for one class of vessel, one particular class of vessel, what would the process look like for the scaling for the rest of the fleet? Because I'm guessing that the constraints are different for different classes of vessels. And in that process, what are the key enablers and the key potential constraints that the participants should consider?
Well, in terms of constraints, will be is the time to get to have let's say a sellable product, especially because we are talking about a study, a project will involve a study not only to the actually robot and obviously the project of developing it, but at the same time there should be the portal which need to be developed at the same time, where we'll have to collect in the first instance or let's say the blueprint of the available vessels and categorized and make sure then will become user friendly, faster, and of course then these two systems and once the robot will be functional, make sure that the data and the imaging these twins will create will be suitable and adjustable for the preloaded model within the portal. So is I think the is very it will take a lot of twin and adjustment to actually get to the final product. I mean, is a very interesting and let's say difficult job to make it to put it all together. Yeah. So yeah, I would say is a good challenge.
All right. Thank you, Salvatore. Thank you for your very detailed explanations. Right now, we don't actually have any other questions from the floor for you, but obviously the participants are free to send us emails with their questions if they come up later, and we will help to facilitate getting the answers.